Hey everybody, it's Chief Meteorologist Brad Benovich. Welcome to Weather School for May 26th, 2020. Can't believe it's already end of May. This is our last week of Weather School. Hope you had a great Memorial Day holiday weekend, a long 3-day weekend. Today's topic is kind of interesting because as a young kid, I wanted to be a meteorologist, but if there was one other science that I wish I could have gone into, it probably would have been geology or volcanology. So I've always had a fascination with how the earth works, in particular earthquakes, volcanoes, tsunamis. So today I thought I'd talk a little bit about earthquakes as a topic for our weather school this week, because it is a very fascinating topic, if you ask me. And one of the things that makes it so cool is that when we're talking about the earth, it's a circle, right? It's a sphere. But what people don't really understand is our crust is super thin. And inside is melted rock. The pressure is so high as you go deeper into the Earth's core that heat is created and that melts the rock. And we actually have a molten core. So our Earth, like this ball, you can see I can flex it. That thin crust has got cracks in it. The best way I can describe it, and I hope I don't break this, but is an egg. Okay. An egg has a very thin shell. Essentially, the Earth's crust is about as thin as an eggshell compared to the whole egg. And unlike an egg, which has no cracks in it, hopefully, when you buy it, our crust has a bunch of different cracks in it. In fact, if I show you a picture of the Earth, this is kind of what you would envision it looking like. Basically, the crust has tiny cracks in it that are always moving. These plates, we call them plate tectonics, are floating. These jigsaw pieces of the crust are floating on that melted rock below the surface. And this is what helps create earthquakes, but also changes how the earth looks over time. This video will kind of show you how this works. When the molten rock comes up in the middle of the mid-oceanic ridges, it actually causes new crust to be built. So the earth is always building new crust, but some crust is going back down into the earth and is actually dissipating. This is why at one point in Earth's history, we had a giant supercontinent called Pangaea. You could see it up here in the upper left corner right there. This was Pangaea, and all the continents broke up as the plates shifted and moved apart. So at one point, Africa, South America, North America, and Europe were all connected at one point. And over millions and millions of years, they separated and became the continents we have today, but they're still moving. And that movement leads us to what causes earthquakes. What happens down in our crust is that hot molten core has got convection currents, not too dissimilar to what happens in our atmosphere, believe it or not, when we get thunderstorms develop. But in this case, the hot air rises, it gets to the surface, it cools, and it wants to fall back down. And that helps create earthquakes and volcanoes. Now, the way earthquakes and volcanoes work is when the plates rub against each other. So when the plates rub against each other, two things happen. They rub and they cause friction, which causes shaking, or some of the earth crust goes back down into the core and melts, and that causes hot molten lava or magma in this case to rise back to the surface in the form of a volcano. So there's a couple different types of faults. These are what we call cracks in the crust. So here's a quick little look at a normal fault. A normal fault is just where you see the fault break like that. You also have something called a slip fault. Now, this normal fault is something we'll get back to when it comes to tsunamis. Slip faults or strike slip are two plates that rub against each other side to side. They don't go up and down, they kind of go side to side. But what is very dangerous, and this is what causes tsunamis, are these thrust faults. This is a type of fault where one plate jumps up or sinks. And when this happens over, or I should say under the ocean, it actually causes the water above it to move. And this is what creates tsunamis. This is often a big issue in the Pacific and something we call the Ring of Fire, which is a big, big area around the Pacific where we have several faults that are going down, subduction faults that go back down into the Earth's crust and melt rock. And that causes a lot of these thrust faults because what happens is one plate is going down into another. Now, a lot of times here in the Carolinas, people forget that we are susceptible to earthquakes here in the Carolinas. And I want to show you something, a map of the US that'll show you the risk of earthquakes for the whole US. Now, what this is showing you is the expected number of damaging earthquakes within 10,000. So when you see this chart down at the bottom here will give you the actual number. And I'm going to show you a close-up view of this. I'm going to show you the Carolinas, because one of the things that's happened over the last couple of years is when people hear about earthquakes here, they go, oh, I didn't think we were supposed to get earthquakes. We actually get quite a few earthquakes in a couple locations in the Carolinas. The first location you notice is something called the Eastern Tennessee Seismic Zone. That's this area in the mountains where, remember, the mountains were formed by a collision when North America and Europe and Africa were together. So that settling or rising or lifting of the mountains is still causing some shaking. But one of the biggest threats to the Carolinas is down here in Charleston. The biggest earthquake to occur in the eastern US actually occurred in Charleston in 1887. A 7.3 magnitude earthquake occurred in Charleston, and it impacted everybody on the East Coast. In fact, it caused extensive damage here in the Charlotte area. That damage was quite extensive. In fact, it caused damage all the way up into New York State and all the way down to Cuba. Let me show you that earthquake, because this is a pretty impressive map. This shows the shaking associated with the 1886 Charleston earthquake. If you look carefully, and I'm going to zoom in here, Charlotte is about right there. I'm going to right about there. The earthquake was in there, but we had violent shaking all the way up here into the Charlotte area. Actually, in 1886, obviously there weren't as many people here, but a lot of chimneys broke, a lot of structural damage. It was quite extensive, and you could see the shaking was felt all the way up here into New York, all the way to Chicago. There was even damage in Chicago, parts of Ohio, and even in the Mississippi River Valley, and then down into Florida. So this was a massive earthquake for the Carolinas, and that's why Charleston is a unique location where they have building codes for earthquakes and for hurricanes. It's one of the few locations in the country that has to deal with both types of natural disasters. Now, the biggest earthquake to ever occur in North Carolina was actually really close to Charlotte. Let me show you that map. This is the map of a 5.5 magnitude earthquake that occurred in Hendersonville, just south of Asheville in 1916. This earthquake actually caused the worst damage in our area from a quake, and you can see the violent shaking that took place even in the Charlotte area. Charlotte is right there. There was the quake just south of Asheville. So this was a 5.5 magnitude quake. There also was a large earthquake not too long ago up in Virginia that caused damage here in parts of North Carolina. So we get earthquakes, and just to show you the number of quakes we've had, this is going back, I think, to about 1890, showing magnitude 3 or higher earthquakes here in the Carolinas. I'm going to zoom in a little bit on this one, make it nice and big. So you can see Charlotte is right here. We've actually had a couple 3.0s or bigger here, but in the mountains we get a whole bunch. And then look at the big bullseye over the Charleston area. You see the 7 there. And also notice up here in parts of Virginia, this was the Virginia earthquake 5.8 that caused damage in, but I remember that quake because it caused shaking down here in the Carolinas. So we get earthquakes in North Carolina and South Carolina. They're just not as frequent as quakes out west. The one thing that makes East Coast earthquakes unique is the fact that they travel much longer distances. And what I mean by that is because we don't have a bunch of visible faults, the seismic waves can travel very long distances in the bedrock in the eastern US. That's why an earthquake in Virginia can be felt here in Charlotte, or an earthquake in Charleston can be felt over the whole East Coast. There's a reason an earthquake on the East Coast would look like this and affect such a large area, where out west it would affect such a smaller area. So while we may not get a lot of earthquakes compared to the West Coast, our earthquakes shake over a much bigger area. Now, a really cool thing you can look at online, if you've ever interested, is looking at seismographs. We have quite a few seismographs, and seismographs are essentially a network of stations that measure ground shaking. This is how we determine if an earthquake has occurred. And what happens is seismic waves propagate out in all directions when an earthquake occurs. And what you're hoping is to get at least 3 seismic stations to detect it so they can triangulate the position. As more stations feel the shaking, they will collect data and enhance the information. In fact, an earthquake anywhere in the world can be felt across the entire world, because even though we don't see or feel the shaking, those waves are traveling in that molten core. Remember, inside the earth, it's liquid. It's liquid rock. So those waves will travel all the way across the world and will be detected even on these seismographs. So some of the seismographs we have around here, let's see if we can look at one in real time. We'll bring up one. So not a lot of shaking going on. This is actually called Dogwood Stamp Mountain in North Carolina. And you can see there's always some subtle shaking. That's probably just trucks driving, but no major earthquakes detected here in any of this seismograph. Let's look at one a little bit closer. I'm gonna try to see if any of these are working. Sometimes they're not working. We'll look at one down here in northern York County. This one is a shallow one, so it shows a lot of shaking. This is probably because it's so close to the surface. It's detecting every little shake or bump. And it just goes to show you the type of seismograph will detect different things. So that one's a little too sensitive. Let's look at one up in South Mountain State Park. And you can see that one's much calmer. So it kind of gives you an idea if we go between the two, the type of seismograph and where they are. Also notice when we look at this map, how many seismographs they have around the Charleston area. This is because they want to keep detecting if they're still shaking. That big quake in 1886 actually was centered in Somerville, right about there. So they have several stations that surround Charleston. Also, the New Madrid fault zone, which is here in northeast Arkansas, southern Missouri, Illinois, western Tennessee, Kentucky, northern Mississippi. There's quite a bit because there's a lot of activity there. Remember, if we go back to our risk map again, you can see the areas where we get the biggest shaking in the U.S. There's a big bullseye right over the New Madrid zone. And then there's the West Coast. There's eastern Tennessee. And then there's the Charleston area. Also over Oklahoma, this area has ancient faults which are being reactivated by fracking. And it's not so much the fracking process as it is the injection of the wastewater back into the ground. So some of these are induced earthquakes, we call. All these boxes you see are areas of the country where we've detected man-made earthquakes or induced earthquakes because of injection of wastewater from either oil or gas exploration. So some of that is happening, especially in southern Kansas and parts of Oklahoma. So little things about earthquakes in the Carolinas. They're not as rare as you might think. We get many more than you would consider here. And the big difference here in the eastern U.S. is if there's a big earthquake in a surrounding state, there's a very good chance you're going to feel it here in North Carolina, including the Charlotte. The earthquakes have always fascinated me because of how the whole earth is connected and moving. We average about, I'd say, 30 to 40 quakes in our area per year. And since 1890, I think the number of quakes, let me look. I have to pull this map back up because I think it shows, I had a map that showed a number. There's been like 3,000 earthquakes in the Southeast since the 1880s. So we do get quite a few earthquakes here, even though it may not seem like it. Maybe we just hear about them more, but it is something that is pretty normal for our area. So hope you enjoyed today's topic on earthquakes. If you want to learn more about earthquakes, usgs.gov is a great website. You can track earthquakes in real time, but there's a lot of great teaching tools there to learn more about earthquakes and how our Earth's crust geology and everything works together, because it is a very fascinating subject to me. Like I said, if I wasn't a meteorologist, I definitely would be. Hope you enjoyed today's weather school. As always, if you miss any episodes, you can go back and see them on our YouTube page, WCNC.com or WCNC's YouTube channel. And we've got a playlist now, 50 episodes of WCNC's weather school. We'll see you back here tomorrow at 1 o'clock. Again, final week of school. Field days are next week. So hope you enjoyed the last week of WCNC's weather school. We'll see you back here tomorrow.